This new video will show you the way that we can work on a Phet Colorado simulation on waves. So you have to go back here and select from the subject physics, you click sound and waves. And if you go down there, you can see wave on a string. This is the simulation we're going to work on. So you click on it and then it starts loading. So you can see a string over here and you go and select, first of all, oscillate, not manual. You can see it. Then you select no end. So we have something like this. And then you go down and you put zero damping and the tension to be low. Okay, let's pause it for a while. Now, we can also click on rulers, so we can have a ruler in order to measure some distances I'm going to explain later. So let's go back now and show you again. Oscillate, no end, zero damping, low tension, and rulers. Okay, we pause it, and now we can choose some magnitudes to work with. For example, we go to frequency and we click on it. You can see that I go and decrease it. But let's choose a rather small frequency around 0.5. Let's put it exactly 0.5 hertz and let it go. You can see something like this, a new wave, a transverse wave being produced and traveling to the right. Okay, let's pause it now. We can take the ruler and you can see that if we go and put the origin at the top, at the crest over here, you can see that the other crest to the right, the nearest one, is at a certain distance which is measured using the ruler to be 2.5 centimeters. You have to recall that this is the wavelength of the wave, which means that doing this, repeating this process, you can measure the wavelength and you can go down there if you want, and you can do it in the same way by measuring the distance using the ruler between two consecutive troughs instead of crests. It's the same thing. So let's say that we have measured a certain wavelength. And now we move the ruler back again. And now we want to change something. What can we change? We can change the frequency. For example, let's double it. Let's put it equal to 1 hertz and repeat the process. And now let it go for a while and then pause it again. Take your ruler again, and now you can see that the horizontal distance between crest and the nearest crest is half what we had measured previously. If you remember, we had measured 2.5 centimeters as the wavelength, and now you can see is 1.25, which is just half of it. So doing this again and again, I'm going to send to construct, I would say, a lab report, a table. You have to fill in the blanks of this table. But what I'm trying to show right now is the way to work using this simulation. So we're going to make, let's say, 4 or 5 trials. You take measurements again and again, and what we want to do is to check our understanding regarding the relationship between frequency, velocity, and wavelength. For now, we have explained what's happening when we change the frequency, but we have uh, the tension being constant. As you can see, I had chosen low tension. We have to know that tension determines the velocity of propagation of the wave. So if we change the tension, let it be medium, and we continue the simulation, you can see that the wave is moving, is traveling faster. Now, let's pause it again. you can see now that we have changed uh, the velocity, and as a result of it, we have a change in the wavelength, but the frequency is constant, 1 hertz. So we have another result to discuss about. When the frequency remains constant, if we change the velocity by changing the characteristics, the properties of the medium, in this case, one of the properties is the tension. We can discuss about other properties like the mass per unit of length or others that there's no need to discuss more in detail right now. But changing the tension, you can see that we have changes in the velocity and thus in the wavelength. So let's summarize. Using this simulation, we can do a certain experiment, a virtual lab, doing this. Let's keep frequency first and play a little with the relationship between velocity and wavelength. And then, if we keep the velocity constant, we can play a little again and check the relationship between frequency and wavelength. That's all. You can practice a lot, and don't forget that the way I showed you must be followed by you in order to write down the lab report. Thank you so much.